Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or you want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI pipelines, they just launched dedicated CPU instances. In addition to that, they just launched a new data center in Toronto, and they've got one opening in Mumbai at the end of 2019. Go to pythonpodcast.com/linode, that's Linode today, to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of the show. And to keep track of how your team is progressing on building new features and squashing bugs, you need a project management system that can keep up with you, that's designed by software engineers for software engineers. Clubhouse lets you craft a workflow that fits your style, including per-team tasks, cross-project epics, a large suite of pre-built integrations, and a simple API for crafting your own. With such an intuitive tool, it's easy to make sure that everyone in the business is on the same page. Podcast.init listeners get 2 months free on any plan by going to pythonpodcast.com/clubhouse today and signing up for a free trial. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference. Coming up this fall is the combined events of Graph Forum and the Data Architecture Summit. The agendas have already been announced, and super early bird registration is available until July 26th, where you can get up to $300 off, or the early bird pricing for $200 off is available through August 30th. Use the code BNLLC to get an additional 10% off any pass when you register. Go to pythonpodcast.com/conferences to learn more about this and the other conferences, and take advantage of our partner discounts when you register. And also, the Python Software Foundation is the lifeblood of the community, supporting all of us who want to run workshops and conferences, run development sprints or meetups, and they also ensure that PyCon is a success every year. They have extended the deadline for their 2019 fundraiser until June 30th, and they need help to make sure they reach their goal. Go to pythonpodcast.com/PSF2019 today to make a donation. And if you're listening to this show after June 30th of 2019, then consider making a donation anyway. And you can visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And if you have any questions, comments, or suggestions, I'd love to hear them. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host, as usual, is Tobias Macy, and today I'm interviewing Meredydd Luff about Anvil, a platform for building full-stack web applications entirely in Python. So, Meredydd, could you start by introducing yourself?
Oh, yeah. Hi, Tobias. Thanks for having me. So my name is Meredydd. I'm from Cambridge in the UK. And for the last few years, I suppose, my primary identity has been I run Anvil. It's a tool for building full-stack web apps with nothing but Python.
And do you remember how you first got introduced to Python?
So this is an odd confession this early in a Python-focused podcast, but Python wasn't like a central language for me initially. So Anvil originally started when a friend and I, Ian Davies, my co-founder with who I've known for years and years, we did our PhDs together at Cambridge, and we spent a lot of time grousing about web development. And there's a lot to grouse about at web development, and I'm sure I'll get round to that later. But eventually we decided to stop grousing and actually spend some of our project time building something we thought would be better. And so we were looking at this tangle of applications, languages and frameworks. And I mean, if you think about the web, it's ridiculous, right? The entry requirement for building a web application is HTML, CSS, JavaScript, something on the server side, maybe Python, maybe Ruby, maybe something else, SQL for your database. That's 5 different programming languages just to get started. And then you've got a framework for pretty much all of those, right? You've got something like React for JavaScript and Bootstrap for CSS, and maybe Redux for JavaScript as well, and then maybe something like Django or Flask for the Python, maybe something like SQL Alchemy for the database. And we were looking at that going, well, hang on a sec. Back in the 1990s, right, when we started programming, you could pick up a tool like Visual Basic or Delphi, and one language would be enough to, not just one language, in fact, but just being able to program a bit would be enough to build a whole application that worked the same as every other application on your desktop. And in those days, that was Windows desktop apps. And these days, the bar for doing that is so much higher. And, none of that's like, okay, some of it is, but most of it is not inherent complexity. It's incidental complexity. It's accidental. It's nothing. None of the complexity you're dealing with is really necessary to express the application you want. And we thought that's something we should bring to the web. And so the moment we thought of that, that's really where we thought, well, okay, we're going to want to unify this in one language, because one of the problems is all these languages coming out of your ears. What would be the obvious language? And we very quickly decided on Python, even though it wasn't either our primary languages at that point, because it was so obviously best suited to the task. It is so approachable to people who are used to different languages. It's the world's favorite first language, and if you're trying to reduce complexity, then like picking a language that prioritizes simplicity and readability was an obvious choice. So that's the point where we actually really got into Python. Ian likes to joke that I learned Python by hacking on a compiler for it, which isn't quite accurate, but it's not a million miles off the truth.
It's always interesting to start trying to learn a new concept or technology by going from the bottom up instead of the top down. So it's
yeah, I tangled with Python before a little bit, so I vaguely knew what I was doing. But yes, that was enormously fun.
And so can you talk a bit more about what Anvil itself is at this point? And you've already shared a bit of the story about how it got started, but maybe some more of the actual early days of Anvil.
Sure. So Anvil it's two things, really. It's a web-based development environment, so an IDE, where you can build applications in your browser with nothing but Python, and then it's a hosting runtime environment where you can deploy them. So the idea is instead of the normal web stack where you have, your data starts as rows in a database, then you have to turn that into model objects on the server, and then you turn that into like JSON over HTTP, and you turn that into JavaScript objects, and you turn that into HTML DOM, and you turn that into pixels. We wanted a unified representation. So it's Python objects everywhere. It's Python code everywhere. So if you use Anvil, you pull up Anvil.works, you open up the IDE, you use a drag and drop designer to design your user interface. And then if you double click a button or something similar, you're then editing Python code that runs in the browser when the user opens your app. And then with one function call, you can get to Python code running on the server, so hosted in a serverless environment by us. And that is how you build your application. So instead of all these different forms for your data to be in, your data is in Python objects being manipulated by Python code right the way through. And then, of course, one-click deployment, and your app is live on the internet. So the impetus behind creation, as I mentioned earlier, was Visual Basic and Delphi, and similar environments. There were tons of them. Allowed you to get from zero to a working application with, sometimes with only a bit of programming knowledge. Sometimes you knew a lot of programming, but you were just in a hurry. And we really wanted to replicate that experience. So the idea really started shortly after Ian and I finished our PhDs. His PhD is in human-computer interaction. Mine is in usable programming systems. So we had spent a significant amount of time griping about web usability. And at a certain point, we just said, thing that needs to exist, Visual Basic for the web. And we started it as a kind of hobby project in like evenings and weekends on the basis that, even if nothing else came of it, this is a thing that it will be totally worth us building and putting out there because we would use it even if nobody else would. And then after, several months of development, I think over a year, we finally put up a link to it on Reddit and discovered that we were not the only ones out there who were very enthusiastic about this. And from that point, we went, okay, hey, this is a real thing now. We should make a proper go of this. And so we went full time on the project and we have been ever since, really.
And so for the initial development period, were you just doing it sort of nights and weekends in addition to whatever you were doing as full-time work, or did you have sort of a seed amount of money that you could use to support yourselves while you were getting this off the ground?
We are incredibly lucky to be entirely bootstrapped, actually. So we didn't have to go getting seed money or permission from anybody to do it. It was just, as you say, nights and weekends. I was consulting at the time, and so I just took myself down to 4, then 3, then 2, then 1 days a week. Ian was working as a postdoc at the university, which is a very flexible thing, and he just went down to 4 days a week on that. The company's actually called the Tuesday Project because it was always Tuesdays that we met up to work on it, and even when it wasn't a Tuesday, we relabeled whichever day it was to be Tuesday for the purposes of scheduling.
That's an interesting little tidbit of background information.
Yeah, and so we worked up, and it was great, honestly, having a cushion like that. I mean, it's sort of both hackneyed to say and somehow underappreciated that there are very few fields in which you can do that. I mean, spinning something like this out of thin air in nights and weekends is possible. We are extremely lucky as a profession as a whole that this is an option. And I am personally extremely grateful that we didn't have to go do a song and dance to investors. We could sort of slowly and methodically build something that we thought was technically right before we started doing the sprint to customers, pivot sort of thing.
And so in terms of the early launch of Anvil, you mentioned that you posted it on Reddit, but I'm curious what the sort of early days of users coming onto the system looked like, both in terms of volume and in terms of the overall load on the platform, and any early assumptions that were challenged and needed to be reconsidered as you continued to build and grow the product.
Absolutely. So when we first put it out there, we had some ideas. We thought, well, this would be a platform for simplicity, and the thing we put out there was the smallest thing we thought was even slightly usable. And we very, very rapidly learned what the biggest missing things were. And I mean, honestly, when we put it up on Reddit, just to be clear, like, this is a point that I don't think there was even a payment page. Right, there was a sort of free for non-commercial use. Contact us if you want to use this commercially. Sort of that level of maturity. We're not talking a polished product, but so in the original incarnation, when we were first playing with this in nights and weekends, we were thinking that the biggest problem was in the front end, and that actually, if we sort of built something that people design their UIs without writing HTML and write front-end behavioral code without having to write JavaScript, and communicate with server-side code without having to deal with HTTP and REST and mashing everything into JSON on the way, we thought that would be the big problem. And we actually discovered that there was still a whole bunch of unsolved stuff on the server side. We originally shipped Anvil with like a built-in ability to back your applications off like Google Sheets, because we were thinking, okay, databases are too complicated, but you should be able to at least read and write spreadsheets. And if you're beyond that, then you'll know how to use databases. And one of the things we very rapidly discovered is, in fact, that's not true. And there was quite a craving for, okay, so how do I set up a real database? Oh, you mean I have to go to RDS and to start up a virtual machine and put Postgres on it, and that we realized that was causing people in the wild much more pain than we thought it was. And so I think that was the biggest thing. It was realizing that there were back-end headaches to solve as well as front-end ones. And that was basically, so we put it up on Reddit in I think it was May of 2016, and we did get some customers. And this is something that I've been involved in a couple of startups, and this is one of those merciful things the universe sometimes does to you. We picked up very quickly a couple of really great customers who are exactly who we thought would benefit from Anvil, just to give us a little bit of encouragement to show that sure enough this was possible. And they were paying us some tiny number of bucks per month. And then after that, it was a long fallow period, because we were engineers and researchers, and we had no idea how to, get out there, get in front of people's faces, make some buzz. We just built something, and that little burst of interest we got once got us, some like low trickle of Google traffic, and like one or two perfect customers to reassure us that we were onto something. And then the next few months was a long slog of building a bunch of stuff that we knew we were desperately lacking. And I'd say like the platform started to become, I'm really astonished by the tenacity of some of those early users. Looking back now, how much that we still had to do, that they stuck with it and were able to do such amazing things with it in sort of summer, late 2016. But within a few months, we'd filled in the biggest gaps, and then we felt like we were okay. We were ready to sort of go back to the well, if you like, and say, okay, this is actually we've learned it was a good idea. Now it's usable.
So web applications in general come in a pretty wide range of varieties and categories, from just a simple web form up to fully interactive, immersive experiences powered heavily with JavaScript. And so I'm wondering what the primary format of web applications are that Anvil supports building, and the limitations in terms of what is sort of easy to build, because anything is possible, but what is sort of easy and well-trodden in terms of the formats of applications that Anvil is designed to help people build.
So I should start by saying that, of course, you should be able to do everything with Anvil, and anything you can't do is a bug report. Frankly, things it's not straightforward to do are bug reports too. Having said which, the sort of the most common use case we see of Anvil is for single-page applications. So you go to the application, it loads this, there's Python code that runs in your browser, and you sort of you interact with that. So it's not like a page-based paradigm. It's it's an application you open. So it's not specifically geared towards like a content-driven websites, right? You wouldn't run BBC News website on it, but you would write a mail client in it, that kind of thing. As you've alluded to, a lot of applications do end up having quite deep needs of the web API frameworks. So the web is an extremely deep and complex development environment, right? There is a lot to it. This is, part of the problem of the complexity is there is so much to it. And Anvil is necessarily an abstraction over the web. We take the web in all its complexity of all these different programming languages and all these different network protocols, and we present you with a way of using this that is much less complicated. And the trade-off to that is, of course, that abstraction is never going to be complete. There's always going to be something that you can do with native JavaScript, for example, that you can't do with Anvil. Or indeed, something you can do with certain pieces of server-side code that you can't do in our serverless environment. We try very hard to make sure there is always an escape hatch. So there's this happy path of, all my components are Python, everything was designed with a drag and drop designer, everything runs in my serverless environment. But at each of those points, if you realize that you need something the abstraction doesn't give you, you can reach out an escape hatch and use the native underlying functionality. So, for example, recently, somebody wanted to use Bokeh, I think it's pronounced, the visualization library. And, we don't have native support for that. We do have native support for Plotly. You can just drag and drop it in, use the Python API. We don't have built-in support for Bokeh. And if it were a closed system, that would be the end of it. That would be, the answer is you couldn't do that. But what you can do instead is drop down to JavaScript and write a little bit of raw HTML and raw JavaScript, and then plug that into your Python code, and then call into JavaScript from Python to create this Bokeh visualization, and then wrap this up in custom component that appears in our toolbox, just like the labels and buttons and so on of the standard Anvil components. Just now there's Bokeh plot next to it, and you can drag that onto your page, and then you can make that a reusable library so other people can use it. And that's the sort of example of what happens. There's a happy path you can do with nothing but Python, and then when you want something outside the abstraction, the idea is that you can reach down to the lower levels of the stack, manipulate the HTML and JavaScript directly, and then bundle that back up into a Python component that you or a colleague or somebody on the internet you've never met can reuse, and now they're staying on the happy path.
And is there a particular category or set of categories of users that tend to gravitate toward Anvil, either in terms of their background or their needs or use cases?
So this is always a fun one because actually talking about the history, we spent a long time trying to guess, what kind of category. And the answer is all sorts of people end up using Anvil for all sorts of things. We've got everybody from one-man bands starting startups to, startups that were started with Anvil and are now substantially larger than one person, to big companies to building internal business workflow apps, data scientists doing visualizations. It's honestly kind of difficult to pin down. But yes, from literally the smallest to literally the biggest companies on Earth have ended up using it, which is quite fun. The thing they tend to have in common, the people who are most enthusiastic about it, is they are Pythonists first. So obviously we get a bunch of data scientists for whom this is an enabling tool. It gives them superpowers, right? One of my favorite stories is actually one of our earliest users, one by the name of Colette Nataf, who started she was a data scientist by background, maths masters and all that, had been involved in marketing and had an idea for an ad tech company, an algorithm for doing automated A/B tests on your Google and Facebook ads. And she actually had this working and up and outperforming the built-in tools, and was kind of stuck in consulting land because, she'd have a client who would ask her to do a thing, and she would, bring up the script on her laptop and point it at that client's account and do the ad optimization. And she needed to have a user interface where clients could do this for themselves in order to become a scalable business. And she looked at, was going to find contractors. It was going to cost her, the best part of $100,000 to hire somebody to build the first MVP of a web interface for her. And of course, everybody knows the first version of something is not the version you're eventually going to want to ship with. That was she was going to have to take a whole round of investment just to make that happen. And the crazy thing is, of course, that wasn't even the difficult part, right? The data science was the difficult part. The machine learning was the difficult part. The web UI was, just having a button that when you click did this thing. And we find there are a lot of people in that situation that actually they need a web UI on the front of something, but the something is much more important. And so, yes, she ended up finding Anvil, and instead of spending $100,000 and taking months to launch, she launched something within 3 weeks and was profitable within 4. And that's the kind of thing we obviously really love to see, but we do see a lot of people like that. So people with a Python background, or just a scientific background or a hardware background.
And so, given the wide variety of backgrounds of the users that you're supporting, I'm curious how you approach overall user experience and usability design in the platform to make sure that they don't run into any roadblocks in the process of trying to get something off the ground.
That's a really interesting question, because implicit in that question is this idea that the web is so complicated. You sort of have to have, if you're going to make it simpler, you're going to be putting almost a kid-friendly interface on it. That, this idea that the web is so complicated that any attempt to simplify it must lose so much that it's basically a toy. And I very, very loudly and emphatically disagree with that premise. The complexity in building a web application is 95 to 99% accidental complexity. It's not necessary, and you don't lose any power or expressivity by taking it away. Again, it's always there behind an escape hatch, but you don't lose any power by taking it away. And so it's not the case that there is, a right interface for beginners and a right interface for professionals. And I think one of the corrosive effects of the web being our primary programming platform, for delivering applications today, is that people have got it into their heads that anything real, quote unquote, anything that can in fact be distributed to millions of people across the world must be built using a staggeringly complex technology stack. And, for most of computing history, that was not true. Since back in the the 1970s, you needed to know a lot down to the hardware to get anything done. But certainly since the 90s. It did not have to be that complicated to get something going. And I mean, really, we in the Python community should know this, right? We use a programming language that is the first thing that you teach, a 7-year-old at their first Raspberry Jam. If you don't know about those are great events run by the Raspberry Pi Foundation for kids. If you have a kid, find your nearest. They are great. But Python is also the programming language used by DeepMind to beat the human brain at Go for the first time ever. And we are sitting on top of living proof that a well-designed system is accessible enough for novices and powerful enough for seasoned professionals. And it genuinely is just how awful the web is from the usability perspective that has brainwashed us into thinking that there must be beginner-friendly and pro-friendly interfaces to everything. So the conclusion of that little rant is that the variety of users does not especially feed into the API design for how Anvil is constructed. Our goal is to make a good API, and we firmly believe that a good API for a component-based user interface is accessible by beginners, and we have existence proof of this from the 1990s. And if you design that well, that is not going to get in the way of the seasoned professionals either. So we don't really concentrate so much on creating APIs for novices and APIs for professionals. We try to create a good programming environment where the simple things are obvious.
And so for somebody who's interested in getting started with Anvil, can you talk through what a typical workflow looks like, and is in the process of doing that, talk through the sort of implementation stack of Anvil itself and where it ties into those different touch points?
Sure. I think I'll probably go through those separately. So in terms of your workflow, if you're creating an Anvil app, you'll log into the Anvil website, you will open up the application builder, you will create a new application. You'll then be faced with a visual designer to design the user interface of your app and a toolbox on the side. And most likely you will design the first screen of your app by dragging and dropping these components onto your page, and then changing some of their properties. So each component, like a text box or a button, you drag onto the screen. You can then go down to the properties window and change things like its font size and its alignment and that kind of thing. You will then respond to an event. So when someone clicks on a button, at the bottom of the properties window is this button. What happens when it gets clicked? And you click on that, and you've now switched from the design you were looking at to a code view, which is the code that runs behind that design. And every one of these pages, these forms we call them, again, VB heritage, is a Python class. And when you double-clicked on that button, you created a new method in that Python class that was, my button click. And that's the code that gets executed when the button gets clicked. And in that code, you'll do whatever user interface. You might do some validation. You might pop up a message. You might navigate from one page to another. But if you want to do something on the server, you will make a function call. So anvil.server.call, you'll specify the name of a server function. And then it's just like a Python function call. So you can pass arguments, you can pass keyword arguments, and you can get return values from that call. So to implement that server call, you'll create a server module, which is they're highlighted differently in the editor, the yellow background for server code. And that's just a Python module that runs on our servers in our serverless environment. And there you write ordinary Python code, but you can define a function, just def something, and then you can decorate it with @anvil.server.callable. And that says this is one of those functions you can call with anvil.server.call from the web browser. And so you define a function, you drop this decorator on it, and this function can do whatever, talk to databases, so on, return some values, and then you can go back to your client code and you just call it as if it were a function call, any other function call in Python. That's really the core of it. There is there is a visual designer, there is code that runs in the browser, there's code that runs on the server. In practice, the first question everybody always asks is, okay, as we discovered when we first put this thing on Reddit, the first thing everybody asks is, so how do I use a database? And of course, you can, spin something up spin a Postgres instance up in Amazon and then connect to it with PsychoPG2, because of course it's just Python, right? You've got all those libraries at your fingertips. But in practice, we discovered setting up databases is a bit of a pain, and so we actually have a built-in database service you can just add to your app. And this has a point-and-click interface for creating tables and creating columns in those tables and so on. And there's actually a pure Python API for interacting with them. So you can go into your server code and you just go sort of apptables.foo.search or apptables.foo.addrow, which has a lot of advantages. It means that we have a straight Python object-based API, which is really cool because we've actually made it so you can return those Python objects. So you can an server function, anvil.server.callable function running on our servers, can go look something up in the database and then return that database object. Whether it's like a search iterator or a database row, you can just return it to the client. You get it as the return value from anvil.server.call in the web browser. And so you can do things like accessing and updating your database directly from the button click handlers in your code, because it's just a Python object that you return from a server function and you can live update it. And this means that you don't have to plumb every operation in your app through from, all the way from the front end through to the database. You can, in fact, return the database row or a view of the database as a Python object from the server and interact with it on the client. So that's what a typical, very simple Anvil app will entail, right? It's got some drag and drop designer on the front, Python code running in the browser, server code running in our infrastructure, a database, again, hosted by us, built in, and passing database objects between client and server with these function calls to implement whatever kind of storage or display you want to. And the really cool thing about all of that is that because they're all just Python objects, they're all in the same programming environment, right? If you're a web developer, when was the last time you were working with something that knew your database schema and was able to use that to provide auto-completion in your front-end code? Right? It's basically impossible with a modern web stack because your database schema is designed in one programming language. You're reading it in something like Python. You're transmitting it over JSON, interpreting it in JavaScript, and then chucking it into some framework that an autocompleter will have a very hard time understanding. Whereas with Anvil, they are just Python objects, and our autocompleter can track them all the way from the database to the front end. So you get all the luxuries we had in the 1990s. All the luxuries you're familiar with if you use PyCharm on a daily basis, you can actually use in a full-stack web application. So yes, designer, front-end code, back-end code, database as objects you can pass back and forward, and it's all auto-completed. How we implement that, which was your second question, is a lot of fun. So obviously the actual running in the browser and running on the server are very different environments in terms of implementation. So the code you write in the browser is compiled to JavaScript and executes that way. The code in the server runs, in either a sandbox for free users or a more capable full Python interpreter inside a Docker container, in a virtual machine, inside a lead-lined box on our servers, and we just have an environment for farming those out. The function calls from the client to the server, they happen over a custom RPC mechanism over WebSockets, and the custom RPC mechanism is what lets us pass back and forth those rich Python objects like database rows. The database itself is backed by Postgres. It's actually implemented as a series of calls, just like anvil.server.call calls that are handled by the central sort of Anvil built-in services. So, but of course, those are wrapped in Python objects, so you can do things like accessing a database row with square brackets, because of course that is just a call to the dunder get item function. So that's a sort of the skimmed view. Oh, I could talk a little bit more about the client side stuff. So all those components you've been dragging and dropping onto your page, so the buttons and the text boxes and so on, are actually they're Python objects. So if I want to, change the text on a label, which is a text component, or if I want to get the text that's in a text box, you just go self.textbox1.text. It's just a Python object with an attribute. And when you go and select that text box and scroll down in the properties window in the visual designer, you're just editing the attributes of that Python object. And that's an example of what I mean about, that's an API design that is pretty accessible to someone who's just started, who, if you know about Python objects and you understand they have attributes, then self.textbox1.text will make perfect sense. But that is also a really good interface for driving things from an expert level, because of course you can, dynamically create these objects and add them to your, and add them to containers on your form. The drag and drop designer is of course just a shorthand for all the ways that you could construct your interface with code, which means that, again, by making them Python objects, they are directly manipulable. You can drive them in all sorts of interesting ways, but there's a drag and drop interface and an easy way of using them. Those Python objects are, of course, they are implemented because they are accessible from this Python that has been compiled into JavaScript. They are implemented in JavaScript as part of our Anvil runtime and made accessible via sort of foreign function interface into Sculpt, which is the Python to JavaScript compiler we use on the client.
Yeah, I was going to ask about whether you use a sort of readily available JavaScript transpiler that's just pip installable, or if you were building something custom for your own purposes. So I'm curious what your selection criteria was for determining sort of which path to go down and which library to use.
So we use Sculpt, which is an existing open source Python to JavaScript compiler. There are, as you allude to, a few of these about. Actually, my colleague Sean Taylor Morgan has written a comparison of Python in the browser mechanisms for Python tips that you might want to put in the show notes. Some of these Python environments, they're meant as kind of drop-in replacements for JavaScript, right? If you look at something like Brython, right? Brython's big sell is that you can do script type equals text/Python, and then you, in your HTML, in angle brackets, and then you can write some Python in your web page. And that's cool if you want to use Python instead of JavaScript, but it doesn't fundamentally change the paradigm of how you're using the web, right? You are accessing the HTML DOM the same as you do in JavaScript, right? You have a document object. And so it hasn't actually raised the level of abstraction. It's just swapped out a language from JavaScript to Python. And we wanted to be more ambitious than that, because that, those layers of abstraction and the need to transform your data into 50 different forms between server and client is a large part of the problem. And so something like Brython, although it is absolutely awesome and you should totally check it out, doesn't actually solve that problem. And so we chose Sculpt because Sculpt was originally created for educational purposes. It's not meant as a JavaScript replacement. It's meant as a Python implementation you can use in the browser, in JavaScript, because obviously, you don't want people who are learning Python for the first time to have to interact with HTML, because that is asking for a migraine. So instead, it's a Python interpreter that you can then, provide modules and objects for interacting with the outside world in whatever way you see fit. And so that's what we did. We used a Python runtime environment, and then we provided objects for, components on the screen and so on that you could interact with, so that we could provide a Pythonic interface rather than writing Python but still having to wrangle basically everything else as if you were JavaScript.
And on the server side, I'm curious what you've chosen for your technology stack there. And also, I know that particularly for the shared environments, you pre-install a number of additional Python dependencies that people can take advantage of. And so I'd also like to hear what your strategy is as far as managing version upgrades without breaking your customers' applications.
So on the server side, we use a couple of technologies. For free users, we use the PyPy sandbox because that is a very low-cost sandboxing method, which means that we can support thousands of free users. For paid users, we use a full Python 3 or Python 2 interpreter running, say, inside, isolated in a virtual machine. And for those, we ship them with, as you say, like a default set of libraries, and those libraries we do update from time to time. We currently do run on like a standard standard requirements.txt effectively. We don't personalize those yet, although that is something that I'm looking forward to on the something I am looking forward to on the roadmap. But at the moment, there are just upgrades, and you can, if you're a paid user, sort of ask us to tell you when something, when certain of your dependencies that you need change. We don't currently have a good change management process for that yet, but that is something that is on its way. So watch this space.
And so for the server side, I'm curious what the environment is that customers are using for running their code there. So whether it's like a Flask app or a Django app under the covers, or if you have built some homegrown web framework for Anvil in order to be able to support the WebSocket communications, or what sort of combination of technologies you're using to build that.
Right. So the code that you're writing on the server is absolutely not a Django or Flask or standard web application. As I say, it's a serverless environment where the way to talk to the client is to expose at anvil.server.callable functions. So what actually happens is that when you open an Anvil application in your browser, that makes its WebSocket connection to a piece of central routing infrastructure that we maintain, and that says, oh well, that request is for this app, and it's not to one of our internal built-in handlers, therefore it's going to be executing in the server-side Python environment. Therefore, route over there to that node, which is hosting a live server-side environment for that app. And so that part is all is custom. So what's actually running inside that VM is a custom Python environment that connects up to this routing infrastructure and distributes requests accordingly. Having said which, you can, of course, build functions that respond directly to HTTP endpoints as well. So you can interact with your Anvil app. Actually, as a more general point, you can interact with your Anvil app by many means other than just opening a web browser, right? Obviously, that's the primary way that people use many Anvil apps, but you can throw together an HTTP API, so you can tag a function at anvil.server.http endpoint instead of callable, and that says that's like a Flask route that will respond to certain HTTP requests to your app. You can also actually use something called the uplink, which I'm surprised I haven't mentioned sooner, which is a way of hooking a piece of code running on your computer or a computer you control into this same request routing infrastructure. So what you do is you launch any Python environment on your computer. Maybe it's a standalone Python script running as a daemon. Maybe it's inside a Jupyter notebook. Maybe it's just a REPL running on your machine. And you pip install the Anvil uplink, and then you go anvil.server.connect with a key that is unique to your application. And when you do that, your code, wherever it's running, on your laptop or on your server, connects up to this central, routing infrastructure, and then you can locally on your machine create an anvil.server.callable function and call that from the front end, from other server modules, and you are there. You are executing. It's like part of your app. You can, from your own laptop, you can access the built-in database with the same API as you can from server code. You can write HTTP endpoints. You can anvil.server.call into the server infrastructure, and so on. So that's significantly more powerful than the server-side code just being a wrapped-up Django app.
And as far as building and growing the Anvil platform and company, I'm wondering what have been some of the biggest challenges that you've faced in the process?
Ooh, so, one of the biggest challenges is when you're building it's just that it's so big, right? When you're building a developer tool, nobody wants something that is half working. It needs to cover pretty much all the bases before it's usable for anything. So, certainly one of the biggest challenges was building a platform this large from scratch. And that was why it was so great for us to build it slowly and not have this pressure of, seed funding that's going to run out. So that would be one of the biggest ones. I'd say the second biggest challenge is sort of getting the word out there and explaining it, because we met at PyCon just a couple of weeks ago, and when we actually show Anvil to people and see a demo, our booth gets piled 3 deep and it's all very satisfying. But it's a little bit like the Matrix. It is difficult to explain, easy to show. And so our biggest challenge is really, as always, I suppose, with programming, it is all about communication and education and communicating what it's about and how to use it. Technical challenges, there have been lots, and they've been fun. I have one of my first significant externally visible acts as part of creating Anvil was modifying the Python to JavaScript compiler Sculpt we use. So I mentioned earlier that those anvil.server.call calls, those are blocking calls, right? You can get a return value from an anvil.server.call, which is really neat for writing idiomatic Python. On the front end, it was really important. It turns out that was not natively supported by Sculpt when we started this, because, of course, JavaScript is a non-blocking language. And so I had an enormous amount of fun modifying the Sculpt compiler to support producing blocking code and how that interacted with JavaScript. I actually gave a lightning talk at PyCon 2017 about that I would love to send you a link to. But ultimately, and there are lots more like that, but ultimately the technical challenges were, as always, nowhere near as much of a challenge as the human challenges. One of the things that starting a startup as an engineer does is it takes you way outside your comfort zone, because, of course, if you just stayed in your comfort zone cranking out software, you could create a marvel that nobody else sees. And there's fundamentally the good you do for the universe is sort of limited that way.
And as far as just the overall features and capabilities of Anvil, I'm wondering, what are some of the ones that are often either overlooked or underused or misunderstood that you think users would benefit from knowing more about?
So I've previously talked about the uplink. I think that's a thing that is often difficult to communicate without a demo, and then you sort of see a light bulb go on behind people's eyes and they go, oh my god, that's exactly the thing I needed. We try to make specific things not difficult to understand, but there is a lot of depth to Anvil. And if you sort of talk about all the depth up front, then you will sort of necessarily overwhelm somebody. So there's lots of little things in the background, like there are whole features like, the uplink, or like the fact that you can create HTTP APIs that we kind of don't hit you over the head with as you first turn up, because you're already taking in this idea that, wait, hold on, I don't actually have to write HTML and CSS and JavaScript for everything. I can just drag and drop some Python components in. That's cool. So I think a lot of the supporting infrastructure, things that you don't need until you need them, and then you really need them. So like ability to respond to HTTP endpoints is a classic version of that. The uplink is a classic version of that. Some people never have to use it. Some people have like a sensitive database that absolutely must stay inside their corporate network, and they just need to be able to expose function calls in their app that run queries against this database. And so I could list them all, but part of the problem is that there are so many of them that you can't sort of list them all at people without their eyes going slightly glazed.
And so, as you mentioned, you have worked very hard to make sure that Anvil can be used from the smallest to the largest customer, and that there are escape hatches to be able to reach outside of Anvil to be able to do things custom. But I'm wondering what the overall limitations are of the platform that you've built, and when it would be the wrong choice for somebody.
So right now, I mean, this is obviously, you're asking me for, this is quite a painful question, because, as I say, anything that it's the wrong choice for is on some level a bug report. Nevertheless, right now, Anvil is not particularly useful for heavily real-time applications. We don't have a lot of like streaming streaming to the browser support. Again, we have sort of designs for how to support that, but it's not implemented yet. As I say, like content-heavy websites. So because Anvil is geared towards single-page applications, then serving like a news website or a blog off Anvil is not currently very well aligned with what Anvil does. Those are the two examples that spring to mind. But as I say, everything that doesn't work in Anvil yet is a bug report that we will get round to fixing.
And you mentioned a couple of times some of the ideas that you have for the roadmap, and I'm curious if you can talk through what you see as being the future of Anvil, both from the technical and the business side.
So from the technical side, we try not to talk too much about the roadmap for the simple reason that you can sort of never win that way. If you say something is coming and then it is late, then you've broken a promise. And if you come up with, something that's actually new and better and much more important, and you do that instead, well, you ended up still breaking a promise, and that might overshadow you having done something cool. So we try to avoid giving too many hostages to fortune on the roadmap, certainly to people who don't have support contracts with us. On the business side, though, there are, if you look at it in the market, there are roughly two ways to sell software. You can go out and convince all the people that might use your software that this will be really good and fun and stress relieving to use and will help them in their day-to-day lives and so on. Or you can go to their boss's boss's boss in a company and take them golfing. And the incentives that those two systems of selling software provide to the quality of the software that results, they're legendary within the community. A lot of software, not all of it, but a lot of software that gets sold to boss's bosses ends up not being that fun to use because that's not what it's being optimized for. And so the biggest thing we are focused on in the business is we do actually, and it's a bit grandiose to say it, but it is actually ultimately what we're aiming for, is we are trying to fix web development. And if you just fix web development for the Fortune 100, then you have not in fact fixed web development. So we want to continue to remain something that is widely usable by a developer who wants to throw something together and can pick up Anvil and just do it in an afternoon without talking to procurement first.
And one thing that I didn't ask yet, but that I'm curious about, is how you ended up selecting the name for the business and the platform.
So an Anvil is a tool you find in a workshop. It's something big, it's something solid, and you use it to build other things on top of it. Plus, the domain name was free.
And so are there any other aspects of Anvil or the work that you're trying to do to address some of the pain points and shortcomings of web development, or anything else about the business or the technology that we didn't discuss that you'd like to cover before we close out the show?
I think I've said a lot of what I want to say. I think web development as currently conceived is massively liberating in some ways because it has, compared with 20 years ago, it's leveled the playing field. It's allowed pretty much anybody to make an app that pretty much anybody else in the world can use. And that was a genuine good thing it did for us compared with what we had in the 1990s. But because it did that one really good thing for us, we have let it get away with a lot. We've let it get away with being hostile to beginners, frankly, hostile to experts. And I think we've become so used to the idea that anything full scale requires that level of complexity that we flinch from anything trying to make it simpler because, we're so used to this level of complexity that we think that anything making it simpler must be turning it into some Fisher-Price toy. And this is a legitimate fear, and you look at some of the systems out there that try to make this easier, and you can find a lot of enterprise drag and dropware that promises you can build applications without writing any code. And sure, yes, that is turning the web into a Fisher-Price toy, but you don't have to do that. You can build something with an industrial strength programming language that keeps all the power that you enjoyed having as a programmer and takes away the wrestling your data into 5 different formats and mashing it into JSON and writing the same operation 5 times just to build a basic application. And I've said it before and I'll say it again. We're Pythonists. we know that this is possible. We know that simplicity does not mean lack of power. And we want to convince people that that is true for the web as well, or rather to show them.
And for anybody who does want to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose a project called pipex that I started using recently. And it's a simple command line tool for being able to install any sort of Python application or command line tool or binary into its own virtual environment, and then it exposes it to your shell environment so that it makes it very easy to use some of these command line scripts from your terminal without having to go through a lot of setup or maintain different virtual environments or have it pollute your overall system packages. So it's been very useful for me. So it's definitely worth a look if that's something that you have found yourself battling with. And so with that, I'll pass it to you, Meredydd. Do you have any picks this week?
I'm going to have to choose Sculpt, the Python to JavaScript compiler we use. I'm sort of using it here as a synodosh for any of these environments that allow you to write Python in the browser, because I do think that it's a big step forwards, and some of them are small steps in that they are adding choice of language from adding choice of language in the browser instead of everyone being forced into JavaScript, and some of them are really exciting changes to how web development can be done. There's actually, as I say, I'll point you at the comparative Python in the browser article written by my colleague Sean, because I think that's a really interesting overview of where this space is going, and I think it is very exciting.
And it just got more complicated too with WebAssembly making it possible to have other languages running in your JavaScript runtime.
Oh yeah, well this is, that's the real goal. Have you seen PyIodide, which is this awesome project that just puts an entire full-size Python data analysis environment into a web browser using WebAssembly? It is beautiful, and that's the kind of power that I'm really excited about what WebAssembly can do.
Yeah, I've seen that come up, and I've taken a brief look, but haven't dug too deep into it. But I'll definitely add a link to the show notes for anybody who wants to take a look at that on their own. And so I'd like to thank you for taking the time today to join me and talk about the work that you're doing at Anvil. It's definitely a very ambitious project, and it looks like you've been able to enjoy a good deal of success and add a lot of polish and usability to web development. So thank you for all of that, and I hope you enjoy the rest of your day.
Thank you. Thank you very much for having me. It's been great talking to you.